Mars was not always what it is today. 4 billion years ago, it had a thick atmosphere, a functioning magnetic field, and liquid oceans covering its northern hemisphere in water that may have been miles deep in places. It had clouds, it had weather, it had river deltas, ancient lake beds, and the chemical conditions that scientists consider the basic prerequisites for life to emerge and persist. Today, it is a frozen desert with an atmosphere so thin it offers almost no protection from radiation, surface temperatures well below freezing, and no liquid water anywhere on its surface. Something killed it. And in 2026, data from NASA's Perseverance rover, combined with updated orbital analysis from the Mars Reconnaissance Orbiter, produced the most detailed timeline of that death ever assembled. What it shows is not a slow and gradual decline spread across billions of years. It is a catastrophe that unfolded with a geological speed that genuinely caught researchers off guard, and whose mechanism holds a warning that extends well beyond the history of one dead planet in our neighborhood. The key to Mars dying was the collapse of its magnetic field. Earth's magnetic field deflects the solar wind, the continuous stream of charged particles flowing outward from the sun. And without that deflection, the solar wind strips atmosphere directly into space over geological timescales. Mars once had a global magnetic field generated by a molten iron core, exactly as Earth does today. Approximately 4 billion years ago, that core began to solidify faster than models had ever predicted. When the core stopped churning, the field it generated collapsed, not gradually, quickly. The 2026 data narrows the collapse window to less than 100 million years, geologically rapid, and the atmospheric consequences followed almost immediately afterward. Once the magnetic field was gone, the solar wind had direct and unimpeded access to the Martian atmosphere. The thick carbon dioxide atmosphere that had kept Mars warm enough for liquid water began bleeding into space. As pressure dropped below the threshold needed for liquid water to remain stable on the surface, the oceans did not simply freeze and stay frozen. They evaporated. The water was lost to space, stripped particle by the same solar wind that Mars no longer had any defense against. What had been a potentially habitable world became a dead one within a window that, by the standards of planetary history, barely qualifies as time at all. The reason the 2026 findings carry weight beyond the history of a neighboring planet is what they reveal about fragility. Mars and Earth formed from the same material in the same solar system at roughly the same time. Mars was smaller, its core cooled faster, its magnetic field failed first. Earth's core is still generating the field that protects this planet right now, but Earth's magnetic field is already measurably weakening. It has lost 9% of its strength in just 200 years. Mars is not a cautionary tale from another world. It is a before and after image from our own neighborhood, and we are somewhere in the middle of it.